In this video, we introduce a whole-body control strategy for humanoid robots in multi-contact settings that enables switching between fixed and sliding contacts under active balance. First, we present the outline of our controller, and then we will show the capabilities of this controller through experiments. An external planner is used to generate a finite state machine. The planned states determine the tasks of the whole-body controller. Using a quadratic programming problem, the whole-body controller computes joint accelerations, which are integrated twice and sent to the position-controlled robot. Normally, the measured and estimated state of the robot is used to close the loop at the task level. In order to maintain the balance of the robot at the control level, we introduce a novel formulation based on Chebyshev center method. The optimal center of mass position and range distribution are computed from the desired contact force and the measured and estimated state of the robot. This method guarantees the dynamic balance of the robot in real time. For sliding contacts, an online friction estimation is implemented. In the following, we illustrate the capabilities of the proposed controller through co-wiping and shuffling scenarios.